All right, I'm going to do a couple examples of some of the hard types of L'Hopital's rule problems where you have to take the natural log of both sides, or when you get these sort of alternate forms of indeterminate form, alternate types of indeterminate form. So I'm going to do number 24 from the homework, which we have the limit as x approaches 1 from the right. Okay, as x approaches 1 from the right. It's not a very good arrow. It's okay. Limit as x approaches 1 from the right of x to the 1 over x minus 1, right? As x approaches 1, obviously 1 approaches, as x approaches 1, x approaches 1. So we have 1 to the, and then we have to the power of, this power is a fraction, 1 over x minus 1. As x approaches 1, 1 minus 1 approaches, x minus 1 approaches 0. And so we have this fraction where the bottom is getting smaller and smaller, which makes the fraction as a whole get bigger and bigger. So that's going to infinity. 1 to the infinity is indeterminate form. And so we need to change this thing around so we can evaluate it and figure out what it is. You can, of course, plug it into your calculator and trace, and you should be able to get, you should be able to estimate the answer. I'm going to set this thing equal to L so that we can take the natural log of both sides, and then and remember that let me try to make this a little bit clearer. Oops, set it equal to L. Remember, our answer that we're looking for is L, right? So now we have ln of L equals the limit as x approaches 1 from the right of ln, right? And actually, I'm going to do my cursive L. ln of x to the 1 over x minus 1. Okay? Having the natural log of that thing allows me to take the exponent down and put it in front. So I'm going to have 1 over x minus 1 times ln of x. Well, I'm just going to put the ln of x here, and instead of multiplying by 1 over x minus 1, I'm just going to divide by x minus 1. Okay? Now, as I approach 1 from the right, ln of x goes to 0, and of course, x minus 1 goes to 0. So now I have 0 over 0, and I can do L'Hopital's rule. So this is the limit as x approaches 1 from the right. And we do the derivative of the top, derivative of the bottom. So the derivative of ln of x is 1 over x, and the derivative of x minus 1 is 1. And as x approaches 1, this thing all approaches 1, because 1 over 1 over 1 is 1, even from the right or left. Okay? So now we have ln of L. That's ugly. ln of L equals 1, which, this is log base e of L, or you could, raise both e to both sides and that kind of thing. And the final answer, you get e to the 1 equals L. And so L equals e. Right? So if you traced this on your calculator, you should have gotten somewhere around 2.718, right? Which is approximately E. All right, let's do another one. This is going to be number 28. So we have the limit as x approaches 0 from the right of 7x to the 5 over ln of x. Okay, 7x in parentheses to the 5 over ln of x. Okay, now, as x approaches 0, 7x approaches 0, so let's see, the base is going to 0. As x goes to 0 from the right, ln of x goes down to negative infinity. Remember, the graph of ln looks like this, right? And as we approach 0, this thing goes down to negative infinity. So, but that's the denominator of this fraction. So a fraction where the bottom is getting bigger and bigger, right? Even if it's in the negative direction, it's getting bigger and bigger. The fraction as a whole is getting smaller and smaller. It's going to 0. So we have 0 to 0, which is indeterminate form. So let's set the same thing as the last problem. Set e equal to L. Take the natural log of both sides. Okay. We'll take the natural log of 7x to the 5 over ln of x. Right? That's not very easy to read. Let's see if I can do that a little better. Okay. Then we can bring that fraction down. So we get the limit as x approaches 0 from the right of, and again, we're bringing this fraction down. I'm just going to, instead of multiplying by the fraction, I'm going to kind of combine them into a single fraction. So we're going to get 5 ln of 7x over ln of x, single x, right? Let's see here. As x goes to 0, basically both the top and the bottom look like this again. Okay, and x, the value of natural log is going down to negative infinity. So we get negative infinity over negative infinity, which is the negatives cancel, and we get infinity over infinity. So we can do L'Hopital's rule. So limit as x approaches 0 of from the right, and we take the derivative. So the derivative of 5 ln of 7x is 5 times the derivative of ln of 7x, which is 1 over x. And the derivative of ln of x is 1 over x. Okay? And so, therefore, the 1 over x's cancel. Okay? And we just get the limit as x approaches 0 from the right of 5, which is just 5. So we have ln of L equals 5. So L equals e to the 5th. And that is that. Okay. I think I'll do one more problem. I'm going to do the limit as x approaches, this is number 30 in the book, as x approaches 0 of 1 over x minus 1 over sine of x. Okay? As x approaches 0, 1 over x goes to infinity, right? It's a fraction where the bottom's getting smaller, so the whole thing's getting bigger. Sine of x also goes to 0, because sine of 0 is 0. So again, we have 1 over 0, 1 over something getting smaller, so this is infinity minus infinity, so that is indeterminate form. Now, taking the natural log of both sides is not going to be really helpful here. What we want to do is combine this into a single fraction, so we need a common denominator. So we're going to multiply this fraction by the denominator of this one over itself. So we're going to multiply that by sine of x over sine of x. This fraction we're going to multiply by x over x. Right? So we got the limit as x approaches 0 of sine of x over x sine of x minus x over x sine of x. Right? Now we have a common denominator. We can combine these two fractions. So we get sine of x minus x over x sine of x. Right? Now as x goes to 0, sine of x goes to 0 and x goes to 0. 0 minus 0 is 0. Okay? And x goes to 0. X times sine of x is 0. So we get 0 over 0. Now we can take the derivative. Okay, derivative of sine is cosine, so we get cosine of x minus 1, because the derivative of x is 1. And then on the bottom, we have a product rule. So u prime is 1, and v is sine x, okay, plus v prime u, so cosine, it's going to be x cosine x, right? As x goes to 0, cosine goes to 1, so 1 minus 1 is 0, and then sine of x is 0 plus x goes to 0, so that's 0. So we have to do L'Hopital's rule again. because that whole thing goes to 0 over 0 still. Derivative of cosine is negative sine x. Derivative of 1 is 0. Derivative of sine is negative cosine x plus, and we're going to have some product rule business here. So u prime is 1, so it's just cosine x plus v prime u, so derivative of, so we're going to have negative sine x times x. Now these, you have positive cosine and negative cosine, so those cancel. As x goes to 0, sine of x goes to 0, so we have 0 on the top, and I'm sorry, I've made a mistake here. Derivative of sine is not negative cosine, it's positive cosine. So these don't cancel. So let me see if I can get back to that by undoing. So those don't cancel. This is positive. This is actually, as x goes to 0, we get negative sine x over, we have 2 cosine. They combine into 2 minus x sine of x. So the top still goes to 0. The bottom, cosine, so we have 2 times 1. Cosine of 0 is 1, so 2 minus 0. So 0 over 2 is, of course, 0. And that's the answer. There's no natural logs or whatever, so that's just simply the answer. And we're done. So infinity minus infinity this time does turn out to converge to 0. But of course that doesn't always happen. That's why it's indeterminate. There you go.